Imagine looking up and seeing a sunrise that dominates half the sky. NASA has recently shared images of an extraordinary phenomenon: the red supergiant star Betelgeuse ejecting an enormous portion of its surface mass. This event, termed a surface mass ejection (SME), released an astonishing amount of material, 400 billion times more than a typical solar flare from our sun. Astronomers have described this as stellar evolution in real time, as the star's massive outburst challenges much of what we thought we knew about the cosmos. What happened to Betelgeuse? Betelgeuse, one of the most prominent stars in the night sky, is part of the constellation Orion, where it represents the hunter's shoulder. Its fiery ruby-red glow makes it easy to identify, even for casual stargazers. With its pulsating brightness and colossal size, Betelgeuse has long fascinated astronomers. This red supergiant is 764 times the size of our Sun. If it were placed in the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, and extend beyond Jupiter's orbit. In 2019, Betelgeuse underwent an unprecedented event, ejecting a significant portion of its outer layer into space. This ejection cooled and formed a massive cloud of cosmic dust, temporarily dimming the star's brightness as seen from Earth. For decades, Betelgeuse had followed a predictable pattern of pulsation, but this massive outburst disrupted its rhythm, leaving scientists to speculate on its implications. Understanding surface mass ejections, SMEs. While stars like our Sun routinely release small portions of their outer atmosphere in events called coronal mass ejections, CMEs, Betelgeuse's surface mass ejection was on an entirely different scale. The SME expelled a staggering amount of mass, 400 billion times more than a typical CME. Unlike CMEs, which involve small parts of the Sun's corona, SMEs result in significant portions of a star's outer layers being violently ejected. This dramatic event caused Betelgeuse to quiver, akin to a bowl of gelatin, as it struggled to regain equilibrium. Astronomers believe that disturbances in the star's convection cells, the internal processes that move heat and plasma, played a critical role. These disruptions caused instability in the photosphere, the visible surface of the star, preventing it from quickly rebuilding itself. What makes Betelgeuse unique? Betelgeuse is one of the largest red supergiants known, and it is relatively close to Earth, sitting between 430 and 724 light-years away. This proximity, coupled with its massive size and luminosity, makes it a prime subject for studying stellar evolution. Despite its enormous mass, Betelgeuse is relatively cool, with a surface temperature of about 3,600 Kelvin, much cooler than the Sun. Yet its sheer size makes it 126,000 times brighter. Surrounding Betelgeuse is an immense cloud of material, extending 30 astronomical units, about the distance from the Sun to Neptune. This cloud is formed from the star's continuous ejections, which occur unevenly and scatter material in all directions. If our eyes could perceive light at all wavelengths, Betelgeuse would outshine Sirius as the brightest star in the night sky. The life and death of a star. Betelgeuse is nearing the end of its life. Like all stars, it is powered by nuclear fusion. Initially, hydrogen in its core fuses to form helium, releasing energy. As the hydrogen is exhausted, heavier elements such as carbon, neon, and eventually iron form through fusion. Once iron begins to dominate, the star can no longer generate energy through fusion. Gravity overwhelms the core, leading to a catastrophic collapse and an eventual supernova explosion. The recent surface mass ejection signals that Betelgeuse is undergoing significant changes. While it is not expected to explode imminently, events like this provide astronomers with a rare opportunity to observe the final stages of a star's life. Implications for the universe. The violent outburst from Betelgeuse is reshaping our understanding of stellar evolution. Observing such a massive ejection challenges existing models of how stars age and die. If Betelgeuse eventually goes supernova, it would be visible even during the day and could outshine the moon at night, offering humanity a front-row seat to a cosmic event of unprecedented scale. What lies ahead? Astronomers continue to monitor Betelgeuse closely. Its unpredictable behavior may offer insights not only into the life cycle of red supergiants but also into the broader dynamics of the universe. For now, Betelgeuse remains a glowing enigma in the night sky, a reminder of the vast and ever-changing cosmos. A star imploding upon itself triggers a cosmic explosion, one of nature's most awe-inspiring phenomena, releasing more energy than 10 billion suns. Stars evolve over time, shifting colors from hot blue in their youth to cooler red as they age, reflecting their stage of stellar development. Ancient Greek scholar Timaeus in 68 AD noted Betelgeuse's reddish hue, while centuries earlier, Chinese astronomers described it as yellow, suggesting it was once a yellow supergiant. Studying Betelgeuse's evolution offers insights into how red supergiants lose mass before culminating in a spectacular supernova. As astronomer Dupree notes, this unique observation allows us to witness a massive stellar event in real time, resolving surface details through Hubble's lens. Yet, the unpredictability of Betelgeuse's recent activity leaves astronomers uncertain if its supernova is imminent. NASA has cautioned that while Betelgeuse is nearing the end of its life, its explosion could still be up to 100,000 years away, a fleeting moment compared to cosmic timelines. Betelgeuse has been a subject of intense study since the 1st century BCE. Recently, astronomer Serena Nance and her team used simulations to model the behavior of red supergiants like Betelgeuse, contrasting their findings with field observations. A sudden and unexpected dimming of Betelgeuse in late 2019 puzzled scientists. By February 2020, its brightness had stabilized, and it began brightening again. This dimming episode was linked to the expulsion of a massive amount of material from its surface, which cooled and formed a dust cloud that obscured the star from Earth-based observers. Subsequent studies in 2022 using the Hubble Space Telescope confirmed that this dimming was caused by a surface mass ejection, a phenomenon never before observed in a star. Betelgeuse expelled material millions of kilometers away, which condensed into a dust cloud, temporarily obscuring the star's light. This marked the first direct observation of such an event, providing a rare opportunity to study stellar evolution in real time. Interestingly, Betelgeuse's 400-day pulsation cycle, a hallmark of its activity, has vanished. Astronomers now hypothesize that the star is slowly recovering, with its photosphere rebuilding and its internal structure vibrating like a struck bell. Despite these disruptions, it remains uncertain when Betelgeuse will ultimately explode. This event could occur tomorrow, in 1,000 years or even 1,000,000 years. When Betelgeuse does go supernova, the explosion will not harm Earth as it is over 500 light-years away, 10 times the distance required for supernova to pose a threat to our planet. Instead, humanity will be treated to a breathtaking celestial display, with a star shining brilliantly in the night sky. For now, Betelgeuse's cosmic drama continues to unfold. NASA's James Webb Space Telescope may track the ejected material as it travels through space, while the Hubble Space Telescope monitors the star's surface changes. Betelgeuse's eventual supernova will provide astronomers with unprecedented insights into the life cycle of massive stars, marking one of the most significant celestial events observable from Earth.